My name is Brett Nixke. I'm from Bross Improved Grazing Group. Bross Improved Grazing Group is a regional grower group that conducts and communicates projects, particularly in the livestock and grazing space for local producers. And we're on the property of Peter and Andrew Kleinig here at Koonunga. They're a livestock, cropping and run a vineyard operation. And one of the projects that BIGG has got is our soil moisture monitoring project, which has been established in 2013. As you can see here is the weather station for that project, and it measures soil temperature, rainfall, wind speed, humidity, and also what you can't see, it measures soil moisture with a probe in the ground. And it's important that for this project, we're value adding to this project by the soil pit in the back by helping determine the soil characteristics and relating to that the soil moisture that's in the ground and throughout the year. This is Peter. Peter owns the property. Peter, this soil information and also the weather station here, how do you use that in your decision making on your property?
I guess there's many ways. I guess a starting point for the season, there's your baseline moisture that's there at sowing time, and you can monitor that throughout the season. Gives you a good handle on whether to apply more fertiliser as the season progresses, and maybe even for cutting hay you can schedule those sort of jobs, whether to leave a pasture paddock for hay or maybe put stock in it if you think it's not going to make it.
Right, yeah.
So as well as I guess it's been handy for monitoring the cold nights as well for the frost events we've been having lately, so yeah, that's been a bit of an eye-opener too.
Yeah. And what about when you come to spray or harvest? Do you use the information that's generated from the weather station also?
Yeah, no, absolutely. The monitoring wind speed and now direction is handy as well with the vineyards around, and haymaking, it's handy to monitor humidity. Sometimes some paddocks will go and you can be a different location and monitor the station and say we can shift back closer to there, it might go. So
And at harvest with your fire index is important too, when to stop harvesting?
Definitely a real time close by figure is really handy at harvest time.
We're just about to have Rebecca Tonkin from Adelaide Mount Lofty Ranges NRM board to go through and tell us about the soil pits.
So this is the Kleinig site at Koonunga, and this is very much an alluvial soil that's formed out of the materials that have flowed out of some of the rocks on the western side of the Barossa Valley. You can see quite deep soil material. If you look down the bottom, there's probably an older soil material down here as alluvial, some more recent clay material, and then some topsoil, and quite deep topsoil that's sort of formed over the top of it. So I suppose reasonably fine material would have formed a lot of this base material through here, and it's quite dense clay, and I suppose on the topsoil a bit more sand and clay involved in that. The rocks on the western side are a bit finer grained, I suppose, than the Kanmantoo stuff out east of Angaston.
Okay, so here we are in the soil pit at Kleinig's place near Koonunga. We're basically towards the bottom of a gently sloping valley, and there's a creek over towards my left running down in that direction. So this is just a nice gentle slope. It's cropping country, as you can see from the stubble, and has been for some time. So when we look at our pit here and see our profile, in the layers, our horizons, we've got our top of the A horizon, your A1. This is where you've got the most roots, it's most active. It's got more of a crumbly structure. Just underneath it, we've got more of a sort of flatter. And if you look at this, you can see there's a kind of horizontal layering in the soil. We call this platy. It's quite often seen on cropped soils that have been cropped a long time, and it comes from previous decades of work that were basically working the soil horizontally. As we've come more into no-till, and reduce the tillage and put more organic matter back in, it's beginning to develop this more crumbly structure and break it up a bit so that we're getting less hard pans, less platiness and more of the crumbly stuff. Hopefully that will work its way down. Then we've got this layer here in the subsoil, slightly bleached, maybe short-term waterlogged occasionally, a more solid, larger structure, but still able to break up with a few roots going through it. Then we have our B horizon. So this is our B horizon here, and this goes down until about 80 centimetres. It changes again slightly and becomes more mottled with red and yellow sort of colouring and a little bit of grey. We've got this beautiful crumbly clay breaking up, quite blocky, strong structure, lots and lots of roots in this. And then down further in the B horizon, this is our subsoil, showing signs of temporary, possibly seasonal waterlogging, maybe a few weeks each year. Still got roots in it. These roots coming right down, taking advantage of the structure and drawing out water from deep in the profile right at the end of the season. So we look at it again and we look at where the roots are, and there's a lot of roots in this profile, which is great. There's a heap in the top. So these are the feeder roots from the crop, and they've gone out and they're looking for all the nutrition and water that they can find. Then we've got this layer down here. Not so many roots here, but they are going through. These are the big ones looking for water. These are searcher roots. And then down here in the clay, these searcher roots have found the clay and they've just proliferated. They have gone out everywhere. They're going right through all the cracks, through all the planes in this cracking clay soil. They're going out, picking up nutrition and water all the way down, travelling old root channel down here, right down to about this level, about 95 centimetres. So if we have a look at the texture of this, so this soil up here, like if we take a crumble, crush it in the hand like this, add a little bit of water. This is powder dry soil, as a matter of fact. It just hasn't rained here for quite a while. So if I give that a good squish in the hand, and from the feel of it, I can rub it between my fingers. It's a little bit slippery, tiny little bit of sand in it. And then when I press it out, like, it's definitely formed a ball, so it's got a little bit of clay. Then I'll press it out and I'll see how much length I get. About 2 centimetres, centimetre and a half. Yep, so what we've got here is a fine sandy loam. It's quite a fine sand, but not a lot of clay. So probably around, say, 8% clay and the rest sand primarily, and a tiny little bit of silt, which is not surprising considering that we're in a valley bottom. If we go down here, because this is obviously quite a change in the soil, so I'll take a crumb out from here, so about 50 to 60 centimetres. I'll crush it a little bit in my hand. So here we are. You can see it's got quite sharp edges. It takes a little bit of effort to break it up, and it looks as if it's quite tough and strong. But then when I put some water on it, this clay just melts in my hand, just like that. So it's already forming a ball. So it doesn't have a lot of resistance to water. And as you can see on my hand, it's just melting there. So I'll work it a little bit more, make sure that there's no lumps left in it. And this has gone really squishy in my hands, just like plasticine. So I know it's got a lot of clay in it. And then I form it into my bolus, and then I press it out. And if it doesn't run away from me and stick to my hands, should be able to just gently press this out. Yep, okay, we've got 6 or 7 centimetres there, so a lot longer than the other one. And I would say this is a light to medium clay, which is approximately 35% clay content. So that's quite a big difference in texture between this up here, which might have, say, 8 to 10%, and here you were going to say 30-35%. And that's sticking together all the way along. So this texture contrast then between this fine sandy loam to loam soil and this medium clay here means that this structure is really, really important, because as water comes through here, which it can move through reasonably quickly, it gets to here and it needs these cracks and crumbles to move through. If these cracks and crumbles swell and fill up, then what you can get is water sitting on top of this clay, and that may be what has happened here to cause a little bit of bleaching in this lighter colour. Some temporary short-term waterlogging if we get a really heavy rainy winter. Some other signs down here that we may have had waterlogging in the past. If we look at this soil carefully, we can see that it's got mottles in it. So I'll turn that around. You can see that there's different shades of dark and light. The red is showing where the iron in the soil has been well oxygenated. So it's an iron oxide, it's rust. And you only get that where you've got a good oxygen supply. Where you've got yellows and greys, it's generally where it's not so well oxygenated. This is where water has been hanging around, and it changes the iron into other forms, and these other forms have colours like the yellows and the greys and greyish browns. So down here, this is where perhaps the clay is getting a bit heavier, a bit thicker, a bit more dense, and in a wet year this is where the water would end up hanging around. And it's interesting that that's also the point approximately at which the roots have stopped at this time. We'll go on to some of the tests that you can do yourself in the field, some basic stuff. So we've got a soil pH test kit. Here I've taken some clods of soil, so this one from right up the top, medium, down, 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 down. I'll drop a bit of pH solution on them. Okay, so this is the topsoil here, and we can have a look and compare it. So that's not too bad. That's about 6.5, maybe tending towards 6. This is the 5 to 10 centimetres, so you can see that's really quite yellow. So definitely 5, possibly getting more towards 4.8, 4.9. Then we have the lower soil, and it's going back, so we're now 5.5 to 6. And on the clay, more like 6.5, 6.5 to 7, and around 7 for the deeper subsoil. So the only part of the soil that's really acidic at the moment is just under the surface, and that's because the surface has got some neutralising from the organic matter that's there, but that hasn't spread down. So you've got this sort of 5 to 10 and 10 to 20 that's more severely affected, which is of course right in the root zone, just where you don't want it. The other thing that we can do to have a look at what's in our soil is to take a crumb of the soil. So we'll just take a crumb like this, and we put it onto in this case, a saucer of distilled water or rainwater. So we need fairly pure water for this. And we put it in there and just leave it there. Like, don't pour the water on top because that'll just break it up. Just still water and put the crumb in there and see what happens to it. So if I put some fresh crumbs in, so here's our topsoil. This is just under the surface here. This is the middle layer. You can see how the soil here is starting to fall apart. This is the top of the clay. You can see how quickly that clay falls apart once it gets really wet. This is the middle of the clay here. And again, a little slower than the upper clay, but it's still gradually falling apart. So you can imagine that if this soil got absolutely saturated, you really wouldn't want to be putting heavy machinery over it. Yeah, you also want to take care with putting in things like roads or dams, because if you cut into this subsoil and it gets water running over it, it's very easily eroded. And in this case, we can see that the upper soil here, with plenty of organic matter, has remained pretty well in its crumb shape. But the lower soil, including this layer, has fallen apart and slumped. It hasn't turned the water milky, so it's not dispersing, but it is having trouble holding its structure together. So this is a soil that likes to be treated very gently, and do as much as you can to hold its structure together by adding organic matter, keeping to no-till, retaining your stubbles, and not working it when it's wet or sticky. So we'll move on to the chemistry. So we've taken soil tests every 10 centimetres down the profile, and also in the paddock around to 10 centimetres. So the first thing that we look at is the pH. And the pH from the lab agrees with the results of our field test kit, which is great. Of course, the actual results are saying that the pH in the top 10 centimetres is about 4.5, and that's a little bit of a worry. That's a level at which aluminium can be released into the soil and it causes damage to plant roots. Underneath that, we've got about 5 at the 10 to 20, then 5.7, 5.9, 6.1. So the pH is increasing as we go down the profile. That's good because it means the acidity is only in the topsoil, which is relatively easy to treat. If it was down there, you just couldn't do it. Then we look at our aluminium and we see that yes, the topsoil has got some active aluminium, some available aluminium. It's at 1.9, which is going to be damaging sensitive crops like, say, barley or lentils. There are some more resistant crops which may be able to ignore that, but you wouldn't want it to get any higher, and if you grow a lot of barley and lentils, you would want to treat that. We also look at organic carbon. It is 1.13 in the top 10 centimetres. Not unheard of for this soil. There would be a lot of soils in the district that would have a similar level, but at the same time we think, you know, that might be able to be improved, and part of that might be treating the acidity so that you can get more growth in the plants, more soil biology, more cycling of the carbon deeper into the soil. And of course organic carbon drops off quite quickly as you get to depth. Right. Available phosphorus is very good in the surface. There would be plenty of phosphorus here for your normal crops, which is great. And your phosphorus buffering index, which is a measure of how much the soil holds on to phosphorus, is on the low side. That's not bad, it just means that the soil will not hold on to the phosphorus and lock it up. On a sandy soil, if it was that low, you'd think, hey, my phosphorus might leach and drain down. Don't think that's a problem here. I think we've got enough organic matter and clay in the soil that that's not an issue. So we've got potassium going all the way down, boron, not an issue. I would say, looking at this, that if you ever had any plant tissue tests done, it would be interesting to have a look at how the boron's going, because surprisingly it's on the low side for this red soil type. Some of them, you know, are much higher. but it is definitely not toxic. Sulphur levels, good in the topsoil, diminishing as you go down. There's actually a little bulge of sulphur about here, which may be sulphur that in the past managed to get washed down through the profile, and it's been deposited in the clay at the end of the wetting front. So if your plants get their roots down here, which they are, they've got a bonus supply of sulphur that they can draw on. In the trace elements, our copper levels are good and remaining so. Our zinc levels also good, iron is fine, and manganese levels are also good. They're even a little high in the topsoil, probably because of the acidity. Acid soils release manganese, and so it's extra available here. It can become toxic at very high levels, but at the moment, fix the pH, the manganese will come back to more of a normal range. Now the cation exchange capacity, which is a measure of the soil's ability to hold nutrition, is moderately low in the upper soil. It'll hold on to a bit of nutrition, but it won't hold on to it too much. As you go down and you get the higher clay amounts, then you get higher ability to hold nutrition. When we look at the cations, now the cations are those positively charged nutrients, calcium, magnesium, sodium and potassium. They all have good to acceptable levels for calcium and magnesium, and very good for potassium. Now sodium's one that we don't want a lot of, and we've just checking that the exchangeable sodium percentage, we would want it less than 6% of all those cations. So up in the surface here we've got a 5.8. Now sometimes when gypsum has been applied, that actually releases a bit of sodium from the clay, and that can put it in the soil solution and it gets measured. So if gypsum's been applied, don't panic if your sodium goes up. Then it goes down in this soil, so we've got 3.7, 3.1, 2.8, 3.8, and then comes up a bit in the clay, 5.4, 5.8. So you can see we're getting close to 6, and that may be the reason that some of this clay slumps and slakes, but it doesn't disperse because it hasn't got that much sodium. And the final thing we'll look at is the water holding capacity of this soil. So this is how much water can this soil store in it. For instance, if this soil was completely dry, it had had every bit of plant available water sucked out of it by a crop, and we had a rain event, then the plant available water, provided the soil could take it in, would be the amount that it takes to fill that soil all the way up again to field capacity. So not waterlogged, just enough that plants can have it. And in this we add up how much the soil can hold. So the loam will take in about 1.1, 1.2 millimetres for every centimetre. And then going further down we've got the clay, and it's a good well structured clay for the most part at the moment, at any rate when it's dry. So this can probably hold about 1.5 millimetres for every centimetre. And if we add all those up to the depth that the roots are, it's approximately 109 millimetres. So from here to here. So if this was entirely dry from here to here, and we had a rain event that filled the whole thing up, you'd have a rain event that did 109 millimetres. Hopefully not too fast. So, and it would be interesting to see this soil when it's wet, to see just how much this clay fills up with water and whether it's a shrink swell clay. It might well be that when this clay gets wet, it swells up, and then in that case these cracks will close up, and you might have the effect that water starts sitting on top of this clay because it's sealed. But as you can see, while it's dry, it is opened right up and the water can go into it. And finally, we'll just look around for like signs of, other biological activity. Mostly what we're seeing here is the roots. Old root channels, heaps and heaps of roots. There's some old grey black channels here. The occasional little sort of hole through here which might be caused by ants or possibly termites. Termites out in your paddock are actually a good thing. They have bacteria in their guts which fix nitrogen, and then the termites deposit that back onto your soil, so that's great. Yeah, a few little round holes here and there where things like possibly earthworms, more likely ants in this drier environment, have been tunnelling through, burying things and so on. Okay, Peter, so we're standing here in your soil pit, in your paddock. What do you think of your pit? What do you find interesting about it?
Well, I guess it's been interesting to see how deep those roots have travelled through the clay. That's been quite impressed to see that, and we certainly regard this soil as being quite productive compared to some of our other soils on the farm, and certainly interested to see that topsoil is starting to become acidic, and that's something we obviously do need to keep an eye on, I think.
That's fantastic. I'm pleased that it's been useful to you. Thank you very much, and thank you so much for letting us use your land.
If you'd like to find out further information about Bross Improved Grazing Group's soil moisture monitoring project, check out our website www.biggroup.org.au. This project is delivered by the Adelaide Mount Lofty Ranges NRM Board with funding from Australian Government's National Landcare Program.